Now we're going to look at some specifics about polynomial functions. We're going to look at three very important characteristics of polynomial functions called the lead term, the lead coefficient, and the degree. And we're going to start off looking at these three ideas in functions, polynomial functions that are in standard form. It really is a simple idea. What you're looking for when you're looking for the lead term, the lead coefficient, and the degree is you're basically just looking for the largest power of x. You can see that this minus 7 in this example, this minus 7 has no x, therefore it is not going to be the lead term. This one right here is x to the 4th power, so this has a power of 4, but this one is x to the 7th power, and so 7 is larger than 4. Therefore, 7 is the largest power of x in this polynomial. The term that has the largest power of x is the lead term. So the lead term here is negative 3x to the 7th. It's the whole thing. It's the number and the x and the power. Okay? So we're going to say that the lead term here is negative 3x to the 7th power. The lead coefficient is just the number part of that. The lead coefficient is the number in front of the x. So the lead coefficient here is negative 3. The degree is simply the power on the x of the lead term. So the lead term is x to the 7th power, therefore the degree is just 7. Not the x, it's not x to the 7th, it's just the 7, okay? All right, now let's try the next one. This one is not actually in standard form. We need the highest power right here would need to go first. So if we rewrote this in standard form, it would be negative 4x to the 11th power. The next highest power is right here, 5. So it would be plus 6x to the 5th. Then this is the constant. We don't want that yet. But over here we have 5x to the 1st power. So plus 5x. And then we can put on our plus 8. Okay, then plus 8. Okay, and now this is in standard form. Okay, now that it's in standard form, we can go to the highest power, which is 11. And therefore, that makes this the lead term. So the lead term of this function is negative 4x to the 11th power. The lead coefficient is the number in the lead term, and therefore the lead coefficient is negative 4. And the degree of the polynomial is the power in the lead term, therefore the degree is 11. Now, you don't actually have to write the polynomial in standard form. You can just look, so this one is not in standard form. All we have to do is go straight to the highest power, which is 4. Okay, 3 is smaller than 4. This doesn't even have an x. This is x to the 2nd power, and this is x to the 1st power. So x to the 4th power, that makes 2x to the 4th the lead term. So the lead term is 2x to the 4th. The lead coefficient is just the number, which is 2. So the lead coefficient is 2. And the degree is the power or the exponent on the x in the lead term, which is 4. So the degree is 4. This other one here, this last one, you can see that the highest power is 13. This one's 10 over here. 10 is smaller than 13. 13 is the highest power. Therefore, negative 27x to the 13th power is the lead term. Negative, let's see if I can squeeze this in here, 27x to the 13th power. Okay. Lead coefficient is just the number, which is negative 27. So the lead coefficient is negative 27. The degree is just the exponent, 13. Therefore, the degree is 13. And that's how we identify the lead term, the lead coefficient, and the degree in a polynomial function that's in standard form. Now we're going to look at how we can identify the lead term, the lead coefficient, and the degree in factored form. Now, one way you could do this is you could actually convert it from factored form into standard form. But when you have large powers like 13 and 15, that can be, honestly, it could take you hours just to do this one, okay? So we have to have a way of being able to identify the lead term, the lead coefficient, and the degree from factored form. Before we do that, I want to show you something interesting. Do you see on this problem and on this problem, we have an x by itself. We have x to the 5th power. It doesn't look like this. It's not inside parentheses. It is not a binomial. So I just wanted to show you down here, note that when you do x minus 0, you get just x, because anything minus 0 is itself. So x minus 0 is equal to x. So if you see x to the 5th, like you do right here, that just means x minus 0 to the 5th power. So this x to the 5th power is one of these. It is a factor to a power, okay? But it's instead of being, we're just not going to write it as x minus 0. That doesn't make any sense. So we just write x, okay? And here we have x to the 3rd power. Also notice that these two factors, instead of being written as x minus 5, it's 5 minus x. Well, this is really important. I want you to understand that this would be the same thing as negative x plus 5. Now this is a little, it looks a little funky, but trust me when I say it's still a factor, okay? It's where the x itself is negative and then you're adding 5, but it's easier to write it as 5 minus x, okay? So that's going to be important in just a couple minutes. So here's basically what you have to do, okay? To identify the lead term, what you're going to do is you're going to take the number that's out front, okay? So we're going to take our negative 7, okay? And then in each of these terms, okay, you're going to take the x and raise it to this power, okay? So what we're going to have here basically is times x to the 13th power. Now you may say, well, what about this minus 2? The minus 2 doesn't matter. It's not going to be a part of the lead term. It'll be a part of another term, but not the lead term. So we don't have to worry about the minus 2s. We don't have to worry about any of the numbers that are inside these factors. Then what we're going to do is we're going to take the x term, which by the way is negative x, and raise it to the 15th power. So we're going to have times negative x to the 15th power. And once we take the a at the front, and then we take each of the x terms to the powers that they have. Now what we have to do is we're going to have to identify whether the lead coefficient is positive or negative. See, what we have here is this is basically negative 1, okay? And so we can actually separate this. We can rewrite this as negative 7 times x to the 13th power times negative 1 to the 15th power times x to the 15th power. So we took the negative 1 out of the x. And now what we're going to do is we're going to do negative 1 to the 15th power times negative 7, okay? And negative 1 to the 15th power, anytime you take negative 1 to an odd power, it equals negative 1. But if you do negative 1 to an even power, like 16, then it would equal positive 1, okay? So we know that negative 1 to the 15th power is negative 1. So this is negative 1, and this is negative 7. Negative 7 times negative 1 is equal to positive 7. So we're going to have 7. Then what we're going to do is we're going to take the x to the 13th power and the x to the 15th power, and we're going to make it a single x. And then we're going to add together the exponents. We're going to add 15 plus 13, and 15 plus 13 is 28. So that's to the 28th power. So our lead term is 7x to the 28th power, making the lead coefficient 7 and the degree 28. Okay. So now let's do that again over here. What we're going to do is we're going to take our 4/9. We've got to take our number. Then here, this x to the 5th power, we're just going to leave it as x to the 5th power because we don't need, it doesn't have the zeros with it, which it doesn't need to have the zeros with it. So we're just going to do times x to the 5th. Then here, we're going to take negative x to the 23rd power. But here's how we're going to write it. We're going to write it as negative 1 to the 23rd power times x to the 23rd power. Okay? And then here, negative x to the 3rd power, we're going to do the same thing, times negative 1 to the 3rd power times x to the 3rd power. Okay? Now, we'll come back to the x's in a minute, but we have here is 4/9. And then what is negative 1 to the 23rd power? Well, that's, so we're going to do 4/9 times negative 1 to the 23rd power is negative 1. So we're going to multiply by negative 1. Then we're going to take this number here. This is negative 1 to the 3rd power. Because 3 is an odd number, negative 1 to the 3rd power is negative 1. And then we're going to take our x to the 5th and our x to the 23rd and our x to the 3rd, and we're going to add up 3 plus 23, that's 26, plus 5. 26 plus 5 is 31. So we're going to have times x to the 31st power. Now, negative 1 times negative 1, that equals 1. And 1 times 4/9 equals 4/9. So that's 4/9 times x to the 31st power. Therefore, our lead term is 4/9 times x to the 31st power. Now, if you have to watch these two examples a couple times, I recommend that you watch them 2 or 3 times until this makes sense to you, okay? And I know what you're thinking. You're thinking, oh, this is never going to make sense to me. Trust me, if you watch the video a few times and really focus and pay attention, you can understand this. It's possible after 2 or 3 times to be able to understand this. Now, on this third one here, you'll see that we don't have a number, so we're just going to start with our x to the 3rd here. That'll be x to the 3rd times. We have x to the 4th power, so we'll bring that down, x to the 4th power. And then here we have negative x to the 3rd power. So, like I said, we're going to turn that into negative 1 to the 3rd power times x to the 3rd power. We're separating the negative 1 from the x, but we're putting both of them to the 3rd power, okay? Now, this is going to be equal to, well, negative 1 to the 3rd power is negative 1. So we're going to do negative 1 times, then we have x to the 3rd, x to the 4th, so 3 plus 4 is 7, x to the 3rd again, and that's okay to have two x to the 3rds. And so 3 plus 4 is 7, plus 3 is 10. So we have x to the 10th power. Okay? And negative 1 times x to the 10th power is just simply negative x to the 10th power. So our lead term is negative x to the 10th power. The lead coefficient is that negative 1. And then the degree is the 10. I noticed up here we didn't do the lead coefficient and the degree. On this one, lead coefficient is 4/9 and the degree is 31. And that's how we identify the lead term, the lead coefficient, and the degree in either standard form or factored form.